So processes and interactions within ecosystems. So first of all, we need to know, where are large-scale ecosystems found? An ecosystem is a community of plants and animals and the environment in which they live. An ecosystem is made up of living and non-living parts. So living would be insects, birds, plants, and animals, and non-living is the climate, soils, rocks. These provide nutrients, warmth, water, and shelter for the living parts of the ecosystem. These parts are interdependent, which, they just depend on each other. What is a biome? It's just a very large ecosystem, such as a rainforest, desert, or savanna grassland. What determines the distribution of biomes? The key influence is rainfall, so the amount and seasonal patterns, temperature, and other influences are relief, which is just the way the land is shaped, geology, and soils. So here's a map of the world biomes. So tropical rainforests are the darker lines, more lines, and savanna grassland is less lines. So you have tropical rainforests here, and then savanna grasslands. Oh no, I think that's also a tropical rainforest, and then savanna grasslands are here and here. So tropical rainforests are about 5 degrees north and south of the equator, and savannas are about 5 to 15 degrees north and south of the equator. So for savanna grassland, it has fluctuations in rainfall. There's more rainfall in March and April, and the temperatures get quite high at around August. For tropical rainforests, the temperatures go above 25 degrees Celsius every month, and rainfall is high in every month. It's very consistently raining. So this is what a savanna looks like, and this is just a rainforest. So where are tropical rainforests and savanna grasslands found? So the savanna grassland is located, so it's found within the tropics in a broad band, 5 to 15 degrees north and south of the equator, between tropical rainforests and hot deserts. So examples of countries are Brazil, Tanzania, India, and northern Australia. What is the climate and vegetation of the savanna grassland? So the climate has a marked wet and dry season. So the wet season is in the summer, with heavy convectional rain. The temperatures are high, so 23 to 28 degrees Celsius. For rainforests, tropical rainforests, they're found between 0 and 5 degrees north and south of the equator. The largest rainforest is found in Brazil, in South America, in the Amazon basin. Other large expanses include the Congo Basin and the islands of Indonesia. The heat and abundant rainfall allow rapid plant growth. So the climate and vegetation of the tropical rainforests, so rainfall about 1,500 to 2,000 millimeters PA. Temperatures reach 26 to 28 degrees every day, and there are no noticeable seasons. So how has the vegetation adapted to the equatorial climate? So you have the ground layer, where you have, the ground level, at the bottom, and shrubs, and so the roots support trees in the shallow soil, and then you have the undercanopy, where you have woody vines that climb to reach the sunlight, the main canopy, where the trunks are tall and thin to reach the sunlight, and then the emergence, so this is the top layer, and the leaves may have drip tips to shed heavy rain. The top leaves sort of prevent a decent amount of water from going to the bottom, and light as well. So it's useful, the tropical rainforest, because it rains so often. To have trees and leaves that prevent all the rain from going to the ground, it just prevents too much water being soaked by the roots of plants. So the key processes of ecosystems, that link living and non-living parts in any ecosystem are nutrient cycles, food chains, water cycles, carbon cycles, and succession. So nutrient cycles. So the nutrient store in biomass of the tropical rainforest is larger because you have a larger quantity of living things. So you have more trees, you have a larger range of animals, and when they die and decompose, those nutrients go into the soil, and that affects the size of the nutrient store in biomass. It's smaller in the savanna grassland biome because, there's less trees. Oh, drilling outside. Excuse that, just had to close the window. There's less trees, less animals, and less nutrients in the biomass. The nutrients... Oh, no, that is in biomass, so in terms of, in the plants and themselves. The size of nutrient store in the soil is small in the tropical rainforest because it rains so often, and that basically just washes away the nutrients further down the soil, so it's not really accessible anymore. Whereas it's larger in the savanna grassland biome because there's less rain, so the nutrients tend to stay near the surface a bit more. In the litter, there's a very small tropical rainforest in the tropical rainforest, so that the litter would just be sort of the leaves on the ground, stuff like that. And again, it's because of the rain, it washes the nutrients into the soil and then further away. But it's bigger in the savanna grassland biome because, again, less rain. Loss to leaching, which is just loss because of rain. Larger, smaller in the savanna grassland biome. Also, hot and wet conditions speed up the process of speed up chemical processes of decomposition. So that's why there's less nutrients in the soil and the litter of tropical rainforests. So there's a thing that explains it here. So the biomass is very large, so there's all living plants and animals. The dead and decomposing living matter at the surface is quite small. And you have things dying all year round and then decomposing very, very quickly because of the hot, wet conditions. Here, the biomass is a little bit smaller, but slower decomposition. Sorry, I had a cough then. Slower decomposition due to the lack of moisture in in the dry season. It means there's more litter on the ground. So you have food webs. So green plants capture the sun's energy via photosynthesis and convert it into glucose. This is passed through the ecosystem via a food chain or web. So you have producers, which are the green plants, herbivores, which are the primary consumers, and carnivores, which are the secondary consumers. Also have the carbon cycle. A lot of carbon is stored in an ecosystem. So all living things in soil and in dead organic material. Climate affects the amount of carbon stored in the different parts of an ecosystem. So for example, in the tropical rainforest, most carbon is held in the vegetation, and in the savanna, most is held in the soil. So, So climate affects plant growth, and therefore how much carbon is stored in plants, and it also affects decomposition, so how much is stored in the soil. Succession. Over time, an ecosystem changes in response to the environment around it. For example, hardy species such as lichens colonize bare rock after volcanic eruption. Weathering breaks up the rock, and lichens add organic material, creating soil. Grasses then colonize the new soil. These decay and add more organic material, making the environment suitable for other plants, and so on. So in the savanna, grass is burnt to retain grasslands and stop woodland developing. So ecosystems need to be maintained because it maintains a steady supply of water to rivers, prevents soil erosion, reduces the risk of flooding, providing natural materials for things like building and plants medicinal use, and providing us food that is being grown. Biodiversity is a measure of the variety of plants and animals that live in an ecosystem. Areas with rich biodiversity, such as the tropical rainforest, are said to be worth protecting, whereas an ecosystem with lower biodiversity... I had to cough again. I'm coughing a lot today. But yeah, ecosystems with low biodiversity, so like the savanna, is not. So, oh gosh. So you have example of biome, which is the rainforest ecosystem. The tropical rainforests are found along the equator in areas like Brazil, Congo, and Southeast Asia. They cover about 6% of the total land area. They contain the most diverse range and highest volume of plant and animal life found anywhere on Earth. There's a continuous growing season. Rainfall totals often exceed 2,000 millimeters a year, and temperatures are high, averaging 25 degrees Celsius. Vegetation is divided into layers, so emergence, canopy, under canopy, shrubs, and the ground layer. Rainforest nutrient cycle. The nutrient cycle in the forest is very delicate. About 80% of the rainforest nutrients come from the trees and plants. Only 20% of the nutrients are stored in the soil. Hot, damp conditions allow for rapid decomposition from leaves that fall. This provides plentiful nutrients that are easily absorbed by plant roots. These nutrients are high in demand from the rainforest's many fast-growing plants. They do not remain in the soil for long and stay close to the surface of the soil. Consumers, like herbivores, eat the plants. When they die, nutrients are returned to the soil by decomposers. Nutrients are very quickly recycled. The water cycle. Roots of plants take up water from the ground, and rain is intercepted as it falls by, different layers of plants. Much of it at the canopy level, so that's just this part. As the rainforest heats up, the water evaporates into the atmosphere together with transpiration forms. As the rainforest heats up, the water evaporates into the atmosphere and together with transpiration forms clouds to make the next day's convectional rainfall. The forest is a great store of water between rainfall events, and rainfall feeds some of the great rivers that leave these forests, such as the Amazon River. And then the rainfall carbon cycle. Plants during photosynthesis absorb CO2 from the surrounding atmosphere. Rainforest leaf systems comprise about 70% of the world's total leaf surface area and account for between 30 and 50% of the Earth's total primary productivity. Rainforests store more carbon per unit area than any other type of ecosystem. When a plant respires or dies, the carbon within the plant is released back into the environment. Some plants are eaten by herbivores, who in turn may be eaten by carnivores. Carbon is then released by animal respiration, and when the animal dies, the soil becomes an important store of carbon from the dead plants and animals. Tropical forests are critical in the carbon cycle of the planet. When forests are cleared and burned, 30 to 60% of the carbon is lost to the atmosphere. So for the savanna grassland, a lot of information, isn't it? Savanna grasslands are found within the tropics in a broad band between 5 to 15 degrees north and south of the equator, between the tropical rainforests and hot deserts of the subtropics in countries such as Brazil, Tanzania, India, and northern Australia. The climate has a marked wet and dry season. The wet season occurs in summer with heavy convectional rain. Temperatures are high throughout the year, ranging between 23 and 28 degrees Celsius. Vegetation consists of scattered trees, drought-resistant bushes, and grasses that can grow up to 4 meters in height. Drought and fire dictate what species survive. Plants are therefore xerophytic and pyrophytic. The savanna contains a huge variety of plants, insects, birds, and animals. This biodiversity makes the savanna lands a popular tourist destination. The nutrient cycle. The store of nutrients in the biomass is less than that in the rainforest because of the shorter growing season and because fire returns carbon to the atmosphere. Nutrients are stored near the surface of soils since it comes from decayed organic matter from the previous growing season. This organic matter decays rapidly due to the high temperatures. The role of fire, whether natural or made by humans, is vital as it helps maintain the savanna as a grass community. It mineralizes the litter layer, kills off weeds, and prevents trees from growing. The most important nutrients recyclers are termites that gather up vegetation and and process it in one spot. The termite mounds become a nutrient hotspot. So the water cycle. The savanna experiences recurrent episodes of drought lasting 4 to 8 months of the year. During the xeropause, or dry spell, plant activities continue, but at vastly reduced rates. Resistance to the drought is more important to the savanna vegetation than resistance to fire. Diverting water for tourists is exploiting local water reserves, leaving plants and animals short on water, so tourist hotels sometimes dump waste into rivers. That's not why they do it, they just do that, which is not very good. So carbon cycle. Tropical savannas cover around 20% of the Earth's land surface, and while they have fewer trees and stored carbon than rainforests or temperate forests, their extent makes them significant in the global carbon cycle. Regular bushfires release many tons of CO2 into the atmosphere. So this is an example of managing small-scale ecosystems in Wales. So these are the Merthyr Mawr sand dunes. So the key services provided by sand dune ecosystems are recreation, coastal events, building materials, and farming. Problems caused by recreation. So marram is trampled and easily killed by walkers, pony trekkers, bikers. So bare sand exposed to the wind and without roots of marram will blow away. This leaves large semicircular holes, so blowouts. Landowners desire beachfront locations for tourist developments and such as caravan parks and golf courses. So that involves levelling sand dunes most of the time. Merthyr Mawr is less than a mile away from Treco Bay. Development and Treco Bay development and 3 from Royal Porthcawl Golf Club. There's problems caused by farming. So grazing animals produce dung. This enriches the soil, and that changes the sand dune environment, making it suitable for other species of plants. So using fertilizer also does the same. Travelling by cattle also compacts the soil, changing the environment again. And if you introduce foreign species, like rabbits, they're not native to sand dunes and they tend to, eat the vegetation there, which prevents the natural process of succession taking place. Trees and bushes are prevented from developing, Trees and bushes are prevented from developing, holding the ecosystem back to its natural climatic climax community of heathers, birch, and oak woodland. This is referred to as plagioclimax, or plagioclimax, I think it is. Afforestation has been used in places to stabilize dunes and prevent coastal erosion, so this affects biodiversity, succession, and natural processes in the dunes. So, for example, the addition of material to enable the dunes to grow, and the addition of acidic nutrients through decomposition of conifers. Other issues, so building groins along coastlines can stop materials being added to dunes, starving them of material to form and build themselves up. This can lead to erosion of dunes or stop formation altogether. So to manage the dunes, you can build boardwalks, have warning signs for the public to tell them not to walk on them. You can plant marram or fence off areas that have dunes in them. So, example of a small-scale ecosystem, sand dunes. So sand dunes are accumulations of sand stabilized by vegetation. Their development needs a source of sand and an onshore prevailing wind. Grains of sand stop when they hit an object such as seaweed or a lump of driftwood. A small dune, referred to as an embryo dune, characterized by pioneer plant species such as sand rocket, is formed. As the pioneer plants grow, the small dunes become stabilized by root systems. The dune gets bigger, plants will die and decompose, adding nutrients and organic matter. New plants are able to grow in a process called succession. Larger dunes, called fall dunes, develop, also known as mowel or yellow dunes. Fall dunes are dominated by species such as marram grass. In time, the dunes stop growing due to a lack of wind-blown sand. They are then referred to as fixed or grey dunes, and a wide variety of plants such as orchid, heather, and bramble cover the dune. Eventually, a climax community is established when the vegetation is in a state of equilibrium with the environment and there is no further influx of new species. The climax community is dominated by heathers and birch or oak woodland. In the sand dune ecosystem, key services include providing the opportunity to develop tourism, acting as a natural coastal defense against storm surges and coastal flooding, and providing sand for building purposes. So, humans can affect biodiversity, flows, cycles, and processes. So sand dunes are rich wildlife habitats for a wide variety of specialized plants and animals. They are delicate and as a result very susceptible to human interference. As mentioned before, recreation. Sand dunes are an attractive place for many leisure activities like walking, pony trekking, trail biking, bird watching, and picnicking. Marram grass is trampled and easily killed. Bare sand is then exposed to the wind, and without the roots of the marram securing it, sand is blown away to leave larger semicircular hollows known as blowouts. Blowouts can persist for a long time, the rich habitat is destroyed and biodiversity reduced. Songbirds such as linnets and skylarks nest on the ground and are easily disturbed by visitors. There's also economic factors. So farmers use dune areas for grazing animals, particularly cattle. Cow dung enriches the soil and affects natural processes and nutrient cycles. Intensive farming introduces fertilizers. Plant and animal diversity is reduced through soil compaction and nutrient enrichment. Sand dunes are also in demand from landowners who wish to develop land for tourist development such as caravan parks, golf courses, or housing. Direct removal of sand from the beach or the dunes for building purposes reduces the sand available to create and expand existing dunes. Environmental. Afforestation has been used in some areas to prevent the movement of mobile sand. This affects biodiversity, natural succession, and processes in the dunes. The introduction of rabbits by people has also had a significant impact on many dune areas by preventing the encroachment of trees and bushes and succession to reach the natural climax vegetation. So this is an example of plagioclimax. Coastal stabilization activities, such as the addition of groins further up the shore, affect the flow of sediment and material available for dune formation. Management as well. So how to manage dunes. So methods used to protect dune areas include erection of protective fencing, building boardwalks, planting marram grass, putting up signs and setting up of sand traps. Fencing prevents people from walking over the more unstable dunes. Boardwalks encourage people to avoid walking over the dunes and stick to pathways. Signs alert the public of damage they cause by walking on the dune, encouraging them to stay away. Marram grass planting and the construction of sand traps minimize the effects of trampling. Plagioclimax definition: the plant community that exists when human actions prevent the climatic climax vegetation from being reached. And that is all of processes, nature actions within ecosystems.